Okay, moving on to 16. We have negative 10 over 2f equals 20 over f plus 100. So here we can just use cross products because two fractions equal to each other. The cross products are going to also be equivalent. So negative 10 times f plus 100 is going to be equal to 2f times 20. So we have negative 10f minus 1,000 equals 40f. I'm going to add 10f to both sides, so now I have negative 1,000 equals 50f. I'm going to divide by 50. So 1,000 divided by 50 is what? 20? 20? Yeah. Negative 20 in this case because it's negative 1,000. Let's double check. So negative 10 over negative 40 equals 20 over 80. Let's see. So yeah, because negative 10 over negative 40 is positive 1/4, which is the same as that. So yeah, we're good. This is the answer. Now we're going to double check. Oh yeah, so it's not extraneous because extraneous would mean f cannot be 0 or negative 100. 17. 6 over p plus 1 equals 7 over p squared. Now, unlike the last problem, there are two fractions in here, but this plus 1 makes it so we cannot use cross products, so it's going to be a little more complicated, but nothing too serious. Again, we could, find common denominator, use it to add these fractions, but I prefer to get rid of the fractions. P squared is the common denominator, so we're going to multiply everything by p squared. Notice I put it on top because that's where things you multiply go. If I was dividing, I'd put it on the bottom. So when I distribute this p squared on the left side, one of these p's is going to cancel one of these p's, so we're left with 6p. And then when this p squared is multiplied by 1, obviously that's p squared. Over here, p squareds cancel out, leaving us 7. Now what we have is a quadratic equation. We know this because there's a squared term in it. When we do that, we would like to set it equal to 0, factor, and then use the zero product property. So we're going to subtract 7. It's equal to 0. I know factors of negative 7 that add to 6 would be positive 7 and negative 1. So we have positive 7, negative 1 equals 0. Now because of this one, we know that p equals negative 7. This is very similar to it's actually the exact same thing we used to figure out restrictions. So if this were on the bottom of a fraction, we would say p cannot be negative 7 and p cannot be 1. However, that's not what's happening here. This isn't the bottom of a fraction. This is a straight up equation. So we say p equals negative 7 or p equals 1. Again, we're looking for any extraneous stuff, but we should double check. So 6 over negative 7 plus 1, does that equal 7 over 49? Well, we need a common denominator. So we can turn this into 49 by multiplying by negative 7. So we get negative 42 over 49 plus 49 over 49 does in fact equal 7 over 49. So that one's good. And then 1, so 6 over 1, that's 6. So 6 plus 1 equals 7 over 1. Yes, that's correct. So both of these are acceptable answers. Let's see. Moving on. I'm not going to do a problem like 18 on the test, so let's take a look at 19. Error analysis. A student wrote the opposite of the expression x minus 8 as negative 8 plus x. What was his mistake? Well, x minus 8 is the same thing as negative 8 plus x. The opposite is when these are switched. So like 5 minus 3 equals 2, whereas 3 minus 5 equals negative 2. So the opposite is when these switch places. But notice in this case, although the 8 switched places, it brought with it the sign. So that's the commutative property of equality, showing that these are equal. So all we did was move the 8 over here and move the x over here. But the x is still positive and the 8 is still negative. It's when you actually switch the sign that you have a negative thing. So notice the 5 here becomes negative 5 and the negative 3 becomes 3. So the opposite of x minus 8 is 8 minus x. Alright, last one. 20. When multiplying rational expressions involving quadratics, explain why it is helpful to factor the quadratic if possible before multiplying. Well, imagine if you were multiplying like x squared plus 3x plus 5 times x squared minus 9x plus 8, right? So first of all, you're going to get 9 terms because you're going to do x squared times x squared times negative 9x, x squared times 8, and then you have to do that again with 3x and with 5. And then you have to combine like terms, and then to reduce you're going to have to factor, but you don't know how to factor things that have a 4th power and a 3rd power and stuff like that. So by factoring first and reducing first, you make the problem easier on yourself and even doable since you don't have the knowledge yet to factor these larger things. It's very similar to like when you're multiplying 49 over 56 times I don't know, 88 over 7. It's like you don't want to multiply 49 times 88 first. You'd rather reduce first, get some smaller numbers here, right? Divide by 8, right? It's actually only like 11. So by reducing first, you just make the problem way more easy, way more easy to handle, whereas you don't want to deal with something that looks like this up here. That is it. Let me know if you have any questions. See you tomorrow morning for math help if necessary. Bye-bye.